Before we actually start, just a quick check. How many of you are able to install and start running Hadoop now? Yes. Good morning, Arpit. Okay, so how many of you are able to start Hadoop? That is the question. Yeah, we so try going back to the 2.8 version. Okay, Nirmit, whatever problems you are facing, please let me know on the separate chat if you're not able to resolve. Just Arshneet, Nishmita, Akshita, Ritik, Rachel, Akash, Tanmay. Who else is able to run Hadoop successfully? Silveria, yes. If I remember from last time, maybe some of the students have not joined yet, but who are able to run it. All right. Okay. So those who are not able to start it and are facing any problems, as I've said, please let me know on the individual chat. And in case, let's say, you're not able to solve the problems, okay, do let me know, and then maybe we'll try and resolve. In some cases, we have been able to do it. In some other cases, students directly have been able to resolve these problems. But in any case, if you are not able to install and run it, you are going to fall behind because we are trying uh, hands-on now, and just observing probably will not help you because eventually in the evaluations you will have to show what you can do in terms of hands-on, and obviously from an external, not exam, job and interviews and other perspectives also, you would be expected to know the various practical aspects of what we are trying. So today what we will discuss are a few more Hadoop HDFS commands, which we had started discussing last time. So maybe I'll just have a quick recap of some such commands with a different example. And then we will try some of the other commands that we did not try last time. So let me just I'll just open command prompt, try something, and then also share the screen. And then you can also try this example. Okay. So
Sir,
yes,
sir, the commands sometimes vary based on the versions, right?
there may be slight variations, but
Okay.
should not be any major changes. So, for example, some syntaxes may have become obsolete, or it may warn you saying that something has been deprecated. But beyond that, it should not be a major problem.
Okay, sir, got it. Thank you.
Okay, so let's try something which we had really started doing last week, maybe just as a quick refresher. Those who are able to run, install and run Hadoop successfully, you can try. Others maybe note down what we are doing, and once you are able to install Hadoop completely, then you can try these commands. So those who have installed Hadoop, first of all, you will have to start the Hadoop services, which means go to the Hadoop sbin folder in the command prompt, and the command prompt should be in the admin mode, right? Which means do something like start, run, and or rather simpler option will be do a CMD here and right click with run as administrator. And once you go to the command prompt in the administrator with the administrator privileges, go to your Hadoop directory. And within the Hadoop directory, go to the sbin folder. And here is star dash all. Now I am not running this because I have already done it and my Hadoop services are running. I'm just showing you what to do. Okay, just give me a minute. I'll be back. Okay, so assuming that you are able to start the Hadoop services, what we will do is open some editor. In my case, it is Notepad++. And here I'm just creating a simple file called as animals.txt, in which I have just put names of some animals. Okay, so open some editor, create some such file. Obviously, what data you put in there is not important. I've just created some dummy data and save this file in a directory which I think we had created last time called as test files. And if you haven't created this directory, do create a separate directory called as test files. In my case, it is d:\test files, and I have saved this file as animals.txt. Okay, once you save this file, so it will mean that we have been able to start the Hadoop services, and we have been able to create and save this file. After you do this, just raise your hand so that once there is sufficient count, we will proceed to the next step. Till then, I'll just be on mute. If you're not clear about something, please ask. Okay, what about the other students who have installed Hadoop? Are you not able to create this file? only Nirmit.
So creating is done. So do we have to upload it as well, right?
We will do that step next, just as a refresh of what we studied last week. Okay, so I can see Nirmit, Silveira, Rachel, Ritik, Harshneet, Nishmita. Okay, let us proceed. So now we will go to the test files directory. Okay, and we will create a directory inside HDFS called as animal2. Last week we have seen, I think, such an example, but just a quick recap. mkdir command allows us to create a directory inside HDFS. Now in the local directory of Windows, we have this file called as animals.txt because we are running it from the same directory, d:\test files, where we have saved this file. From here, now we wish to upload the file inside this animal2 directory inside HDFS, that is Hadoop. So the local file will get uploaded into animal2. What is the command for that? Anyone?
So for what?
Load a file from our local folder
Sir, it
into
will be
Hadoop.
Hadoop space DFS hyphen push, sorry, put and the name of the file and the directory.
Absolutely right. Put which file we wish to upload.
Animals.txt
Yes.
and then the name of the directory that you want to send it to. So animal2. Yeah.
Right. So the put command will allow us to upload the file. There is an alternative to this command, which is copy from local. It's the same meaning, achieves the same purpose. So there are two commands to do this: put or copy from local. Now, because this file would be already existing there, I'm just trying to save it with a different name. Otherwise, it will say that the file animals.txt already exists because we had put or uploaded it just a few moments ago. Wilfred, could you just mute yourself? I think what must be happening, Nirmit, is your JDK in C program files. If that is the case, you will have to do a change to one of the configuration files. Right? So we have tried the put command last week, and today we have just seen that we can use an alternative to that put command called as copy from local. Next, just again, I think a refresh of what we saw last week. I don't know whether we tried the cat command. So the cat command will allow us to view the contents of a file. So we have just uploaded animals.txt file 2 times. Once with name animals.txt, second with name animals2.txt. The same file uploaded 2 times. So if we run the cat command on both of them, we should be able to see the contents of both the files. Those who have problem with the JDK, this particular solution that I am going to discuss next, actually Deepa from your class pointed out to me last week that this is a workaround. So it is for those who have their JDK in program space files. Okay, so open the file name hadoop-env.cmd, which is inside Hadoop etc Hadoop directory. It is for those who have JDK installed under program space files, or they are getting some JDK error. We can try doing this. In most cases, it should solve the problem. Let's try. So go to your Hadoop etc Hadoop Hadoop-env file. Open this file in an editor. So here you will see the entry for Java home, where you must have added the Java path, the JDK path. Now, if this is including program space files, then simply put this in quotation marks or double quotation marks. Okay, then save this file, close all the command prompts. That is, if you have already started Hadoop and you are trying something, close everything, close all these command prompts. Then open a fresh command prompt with the admin rights. And then go to the Hadoop sbin folder and do a star dash all. This is with the assumption that your name node format command had executed successfully earlier. The just last but one step in the installation of Hadoop, where we format the name node. So I'm assuming here that that step was successful and only running all the Hadoop services is failing. If that is the case, then after you make this change, hopefully your Hadoop services would start. Okay. Anyway, try it, and if it doesn't work, again let me know on the individual. So Nirmit, have you closed all the windows and started both Nirmit and Akash? And what are your JDK versions? Tell me what versions of JDK you have. In the meanwhile, for the others, we will proceed with the next commands. Just give me a second. Yeah, 1.8 should be okay. Fine. Then just put whatever errors you are getting, okay, on this chat. Nirmit, I think you have already done it, but just put it separately on the individual chat, and maybe we'll discuss it offline. All right, let's proceed with the next command. Ashneet. Yeah, this warning is fine. Ignore the warning. Okay, let's try the next command. Again, I'm not sure whether we tried last time, but in any case, the ls command, which allows us to see the directory listing of whatever folder we have created or directory that we have created inside HDFS. So here we have Hadoop fs -ls space /animal2 slash. So it will give us a list of all the files in that particular directory. commands that we have tried so far are make a directory, upload a file, view the contents of a file, and view the contents of a directory. That is mkdir put copy from local cat ls. Next, what we will try to do is to create another directory and try to copy maybe a file from here, that is from animal to animals.txt, this file, into that new directory.
What, sir?
Okay, can you hear me? I think I had got disconnected.
Sure.
Okay, so we'll try the next command. So here now we will create a new directory called as animal3. So this is nothing new. We have already created a directory called as animal2. Now we are creating animal3. But what we will do next is we will copy. So copy a file for which the command is cp. How do we write it? Hadoop fs cp. What is the name of the file that we wish to copy? The target is So we are trying to copy the file animals.txt from animal2 directory into animal3 directory. Just as we had done a directory listing of animal2, we can also see the listing of animal3, and we see that the file animals.txt has got copied successfully. Any questions so far? Okay, next we can remove a file. The command for that is rm. So the file that we created just now, by copying, we can try removing the file. So it will remove the file. We once again do a directory listing. Now there is nothing because the animals file has got deleted. Okay, by the way, I'll just switch to the faster network which has come back, which was not working. Just give me a minute. All right, so just go back to the screen. So we first created a directory called as animal3. Then we copied the animals.txt file from animal2 directory to animal3 directory. We verified that that file was there by using the ls command. Then we removed that same file which we had copied using the rm command, and again using the ls command we tried to verify that the file indeed got deleted. So because it doesn't show any directory listing, means that the file has been deleted. Okay. Next, we can also remove a complete directory. So along with rm, if we also use the switch or option -R. It will now delete the entire animal3 directory. All right. How many of you have tried all these commands fully? Okay. Let's continue. Some of the other commands which are not very useful, I'm not discussing. So practically whatever we require. Get is another command that we sometimes require. So let's say we remove this animals.txt file from our local directory. Okay. So if I again do a dir, you will see that this file is not there. So I have simply used the -l command to delete this file. Now we can get this file back because we had uploaded this also inside HDFS. So to do that, the command in Hadoop is the get command. Okay. Get command is to download a file from HDFS. Right? So we say Hadoop fs dash get /animal2/animals.txt. There is no error. It means that it would have downloaded the file. So if you do a directory now on the local DOS folder or directory, we now once again see animals.txt. Okay, so you all should be clear about the following commands now. mkdir, ls, cat, rm, rm-r, cp, get. Okay, so these are some of the commonly used commands with DFS. Any questions, anyone? All right. This completes our background of Hadoop HDFS and the common utility type of commands that we use in HDFS. The next and very important part of our syllabus and in general of Hadoop technology is something called as the MapReduce programming. What is this MapReduce and why are we worried about it? Before we do that, can anyone tell me what are the three layers in Hadoop? We had discussed this last time. Does anyone remember? Okay. Yes, Akash, Jan. The registry, okay. HDFS, fine. What is the correct single answer for all the three? Let's go back to that slide. These are the three layers of Hadoop: HDFS, Yarn, MapReduce. Although they are, I would say, shown here in the reverse order. HDFS is generally shown at the bottom. In the middle, we have Yarn, and then at the top, we have MapReduce. What we have seen is the HDFS layer so far, in the sense that we have discussed how to create directories, upload, download files, rename, not rename, copy or get back files, remove directories. That is the HDFS part. How does it internally work? Of course, we have not discussed. Middle layer is the Yarn layer, which is the resource management layer. Again, we have not discussed the internal working of Yarn yet. And the topmost layer is what we call as Hadoop MapReduce, which is the application layer or programming layer. And that is where we will now focus our attention to. That is also the layer where those of you who aspire to be programmers, application developers, even people who are involved in any data analytics type of project. Okay, so you will be involved in some work around this MapReduce application layer. So what is this MapReduce? So the idea of MapReduce algorithm is to process the data in parallel on your distributed cluster. So it's actually made up of two parts. One is the map part, and second is the reduce part. And that's how we have this name MapReduce. Okay, so internally it also has actually two more steps as we will discuss, but at a high level or maybe as an overall view, we can say that MapReduce is something like a concept or an algorithm or a structure or an idea where we reduce. I will not use the word reduce, it will cause confusion. It will divide the work into two tasks. One is the map task and second is the reduce task. What is the great idea here? That all the map tasks and if required, all the reduce tasks also will run in parallel on several machines at the same time. What does it mean? Let's say, for example, we have, let's say, a large file. So we have, let's say, a large file which has, say, 1 lakh records. And those 1 lakh records are stored inside Hadoop. Now we know how to store those records. So if we have got that file, we would simply do a copy from local or put and upload the file into Hadoop, HDFS. Another point before we even discuss it, currently because we are using a single machine, that is Hadoop is installed on our own respective computers, we are not really seeing the effect of Hadoop. In practice or in real life, Hadoop will actually be running on several computers at the same time. So it will be like a cluster of these computers controlled by Hadoop. So the file that we are storing of 1 lakh records will also get distributed across these machines. So let's say, just for simplicity, there are say 10 such machines on which our Hadoop services are located. And across these 10 machines, we want to distribute this file containing 1 lakh records. So naturally, a very simplistic assumption will be that on each machine we have roughly 10,000 records. 10,000 into 10 will give us our complete file of 1 lakh records. Hadoop will manage how this distribution should happen, how correctly the file, in case someone wants it back, is given back as a single file. So all that will be managed by Hadoop. But currently, what we are discussing is the map reduce part. So what will happen in the map reduce part or the map reduce engine is that if let's say we write some program, for example, suppose we want to find out among all these 1 lakh records, and suppose these are student records. These are records of all the students in several universities, totaling 1 lakh in number, 1 lakh student records. So we want to find out how many students have got marks greater than 75. So we write some program and now we submit this program to Hadoop. Hadoop says, when you are writing this program, you are free to use a programming language like say Python or Java, or there's another language called as Scala. Use any of these languages, but when you are writing your code, make sure that your algorithm or your logic is written according to a specific way of programming, which I am calling as map reduce. Okay, so understand it once again. We as programmers are free to use whatever language we want, provided we have a Hadoop interface for it. The most important point is the way we write this program will be slightly different from how we write a normal program. So for example, let's say we are writing a Python code or Java code to read the records from a file, from a text file. Then we know how to do it. So yeah, I'll come to the question. So we will write this code and the code will execute, let's say by running the Python instructions or inside the JVM, and it will go to the file, it will read the contents of the file, make those contents available to us, and the program would process. Now here, what we are saying is, instead, Hadoop is going to tell us that if you want to access data that I am managing, that is split across several machines, then your style of programming has to slightly change. And you have to follow what is called as the map reduce style of programming. I hope you understand what we mean by map reduce. So it's just a different way of programming. It's not a different technology. So it's not as if you install something called as map reduce or you run a program called as map reduce.py. No, you write your traditional programs, but the way you write now differs. And that is what is called as map reduce programming. How exactly is that done and what is involved is a very interesting concept and nothing complicated, frankly. If you know either Python or Java, or for that matter, any programming language, then all that we require is to simply change the way we write our programs slightly, and you will be able to easily do it. Those of you who enjoy programming will be able to very, very easily understand and do this. So Tanmay's point is the data is being processed by virtual machines as obviously because it can't be a physical machines as it will increase the cost and take more time. Yes. So what Hadoop is going to do, and we are yet to discuss this, is using HDFS, Hadoop is going to distribute the data across different machines depending on how many machines we have allocated to Hadoop. And then when we run the code, Hadoop is going to take the code to each of these machines and it is going to run the code there. When we write the code using the map reduce logic, what happens is the map task or the map program will simultaneously run on all the 10 machines. So the first 10,000 records on server 1 or machine 1 will be processed by map 1, map 2. That is the same program. Programs are not different. Same copy of the program will run, let's say we call it as map 2 on the second server, which has records numbered 10,001 to 20,000 and so on. 10 map tasks will run in parallel. Their output will be combined by Hadoop, will be given to us. Then we will say, now run the reduce task. It may so happen that the reduce task may run only on one machine or multiple machines, depending on how much data we have now. And in the end, we will get the output of map plus reduce. So all the internal complexity of which map task to run on which server and how will it produce the output and how do the parallel processing and join the final output, all that will be handled by Hadoop. So we as programmers are saved from all this complexity. Our job is to simply code as per the map reduce algorithm and leave it to Hadoop. Okay, so this is what we mean by map reduce, and this is what we are going to discuss next and try out also. So since it's exactly an hour from we started, let's take a 10 minutes break. When we resume in around 10 minutes from now, we'll go through the complete idea of what MapReduce is, and time permitting, depending on how long our discussion goes, we may even start some MapReduce related programming today. If we don't get any time because of the discussions, then we'll start it next week. But then we'll at least complete the understanding and the background part. So let's come back in 10 minutes. Hi, let's first complete the attendance and then continue. Division A, we are in 1, 2, 3, 4, 6, 9,
Present, sir.
11,
Present, sir.
yes, 11,
Yes, sir, present.
Sir, they are in 6 also, sir. Run is
okay,
my code.
15, 16, 18, 23, 28,
28 present, sir.
37, 38,
38 present, sir.
40, 41, 4, 46,
46 present, sir.
48,
48 present, sir.
51, 52, 53, 52,
Yes, sir. 52.
okay,
So
53,
51 present.
all right, 53, 4,
54 present, sir.
6,
56 present, sir.
59, 60, 1, 64, 69,
Present, sir.
70, 71, 72,
नाही मुंबईमध्ये दादरमध्ये
73
Anuj,
present,
can
sir.
you please be on unmute?
तिघांचा फोटो काढून त्याच्यात एक मोबाईल दे.
73 present, sir.
Okay, 70, 71, 72, 73,
73 present, sir.
74,
Present, sir.
25, 76, 77, 78,
Present, sir. 78.
80,
80 present, sir.
81, 84, 85,
85 present, sir.
87,
Present, sir.
89,
Present, sir.
91, 92,
91, yes, sir. Present.
92,
Present, sir. 92.
95, 96,
96 present, sir.
97, 98,
So 98 present.
100,
100 present, sir.
103,
99 present, sir.
Present, sir.
104, 105, 107, 108,
Present, sir.
109. Okay, from the chat,
Sir, 104, sir.
I'm taking 60, 16, 2, 31, 96.
Sir, did you mark 99?
This is for division A.
Excuse me, sir.
Yes.
Sir, PRN 77. I got disconnected. So sorry.
A 104 also I'm marking, 77 I'm marking.
Thank you, sir.
Okay, division B, PRN 5,
Present, sir.
7,
Present, sir.
8,
Present, sir.
10,
Present, sir.
12,
Present, sir.
14, 17,
13.
Sir, 17.
19,
Present, sir. 19.
20,
Sir, 20 present.
22, 24,
Present, sir.
26,
Present, sir.
27,
Present, sir.
29,
Yes, sir. 29.
yes, 29,
Hello, sir. 29. Hello. Hello.
29,
Hello. Sir, 29. Hello.
yes, you are audible.
Okay.
30,
29 present, sir.
okay, 30,
30 present.
31,
Present, sir.
33,
Yes, sir, present.
34,
Present, sir.
36, 39,
Present, sir. 39.
43, 45, 47,
Yes, sir.
50, 55, 7,
57. Present, sir.
8,
Present, sir.
3,
Yes, sir.
5, 66,
Present, sir.
67, 8,
Present, sir. 67. Present, sir. 68.
79,
So you
Present,
marked
sir.
67, right?
yes,
Fine, sir.
79,
Present, sir.
82,
82 present, sir.
83,
Present, sir.
86,
86. Present, sir.
90,
Present, sir. 90.
93, 99,
Present, sir.
101, we waste a lot of time on attendance if you're not there at the time I take the attendance. So make sure you are there and you give the attendance whenever your PRN is announced. Okay, it's difficult to go back and forth and just wastes everyone's time. Please don't do that from next time. Let's go back to our discussion of MapReduce programming. What is the idea of this MapReduce? Suppose we have, let's say, some text that we have in our input file. If you remember today, right at the beginning, we created a file called as animals.txt. So here is an example where maybe some other text is there, the color blue, bluebird, the blue sea, flying bird. This is our input text stored across several Hadoop machines. And as we mentioned earlier, Hadoop will distribute the data according to how it thinks is the best approach. So it may put some data here, some data on the second machine, and so on. So how it distributes is up to Hadoop. We are not involved. We'll simply upload the file. Now, we as programmers are going to now take this data and we are going to process it. So suppose in this particular example, what we want to find out is how many times a particular word occurs. It's a word count program. How many times the word the occurs, how many times the word color occurs, and the word blue occurs, and so on. So to do this word count example, we will divide our code into two main tasks, as I mentioned earlier. First is this map task, and second is the reduce task. What will this map task do in this example is it will simply separate all the words. All the words in this input file, it will separate. So this is our map task, and it will also assign a count of 1. For example, it will say the word the occurs once. The word color occurs once. The word blue occurs once, and so on for all the remaining words also. The map task is simply mapping out all the individual words, and it is giving them a count of 1. So when the map task runs, the output that will be produced will be the comma 1, color comma 1, blue comma 1, blue comma 1, bird comma 1, and so on. So this is the output that we see. Now the important point to understand is that this map task is running at the same time on different machines. So it's the same program or same code base as it's called. And the same program is running on this server, on this server, on this server, every server. Hadoop is managing it. And it is in the end giving us these results. Okay. After the map task comes the reduce task. So here are the reduce tasks running. Again, Whether only one reduced task will run, whether multiple tasks will run, we don't know. Hadoop will manage it. But as I had mentioned, between the map and reduced tasks are also two tasks which are not mentioned here explicitly, which are called as sort and shuffle. So what will the sort and shuffle tasks do? The sort and shuffle tasks will bring all the similar words together, or other similar instances of the word together. So the one, again, it's not found. So, sorry, it's here, the one. So both the instances of the word the will be brought together. That is what we call as the shuffle step. Color one, again, it will try to find whether the word color exists after the map task. No. So it will only output color one. Blue one, it will again search whether blue is there. It is here. It is here. So it will bring all the three instances of the word blue together. Next, bird. It is once and it is second time. So both the instances of the word bird are brought together. This is the shuffle step. So shuffle will bring all the instances together. And then we have the sort step, which is actually not shown here, but what will happen as a result of sort is these will be now alphabetically arranged. So first we will have bird. So bird one, then blue one, blue one, color one, flying one, C one, the one. And then this output will be given to the reduced task, which will simply do the tally or totaling. It will say the 2, color 1, blue 3, C 1, flying 1, bird 2. Of course, in the sorted order, not in this order. So what have we done? We have split our logic into two parts. One is called as a map part, second called as a reduce part. In the map part, we simply go through all our data and separate out the words and give the count. Is one. Then we have the intermediate shuffle and sort steps. In the shuffle step, we shuffle this data so that the similar data items come together. Then in the sort step, we sort them, which is not shown here, but it will be actually sorted. And then the reduce task, which will do the final counting. And it will tell us how many times each word occurs in our input file. So this is the way we can write our code. And therefore, as I said earlier, it doesn't matter which programming language you use, provided that programming language has a support for this map reduce type of processing. So you should be able to split your logic. So virtually any programming language will give you this facility. But because the two most prominent programming languages that are used today are Python and Java, therefore, those are the ones which are used most commonly to do the MapReduce programming. Any questions about MapReduce concept? Yes.
No, sir.
If it is clear, then what we will try to do is, as I mentioned, let's quickly start writing some code in order to do some MapReduce work. Now, yeah, you can take a screenshot, not a problem. Okay, so simply take a picture. Okay, so what we will do is we'll start writing the code, and it's actually very simple. When I say start writing, you will finish it off in a matter of a few minutes. But the important point to avoid any confusions is when we are running this code, there will be two steps. First step will not involve Hadoop. Means what? In the first case, what we will do is we will run the code on the local file animals.txt. Okay, so there we will not use the files that we have uploaded inside Hadoop. We'll just run on the local machine to verify that the code is fine. And once we are able to do it locally, then we will also try running the same code inside HDFS. Okay, so don't be confused about this. Let me make it clear once again. We will run this code in two parts or two steps. The first step, we will run the code on the local file, that is the file that we have created on our local machine. So even if, let's say, the Hadoop services are not running, that is absolutely fine. Okay, somebody is not on mute. Please mute yourself. All right. So there we will not worry about whether Hadoop services are running, simply because we'll not use Hadoop services. And then once we are able to run this locally, then we will try running it inside HDFS, which means that each one of you today can try this code, because it doesn't matter whether Hadoop is running successfully or no for the first version, first attempt. Okay. The code that we are going to write is in Python. Initially, we will try a few Python examples. Then we will try a few Java examples. Okay. So the first program that we will try, we will create a specific directory structure just to avoid any complications. So let me get it very clearly, because invariably many students get confused about this. So please create a separate directory for your code. What I have done is something like this. So I have created a directory called as code Hadoop Python. You do not have to create exactly this directory, but whatever you are comfortable with or whatever you normally do if you are writing code, use that standard practice, but make sure this code does not mix with any of your other examples. So do create a separate directory. Where to create, it's up to you. You just want to blindly follow this, create such a directory just to make it easy. And then inside this directory, we will create a file called as mapper.py, a Python program. Again, use whichever editor you are comfortable with. This is the content of the, or these are the contents of the mapper.py file. Very simple file. There are more comments than the code, just because this is the first example and there is a possibility that some of you may not be quite comfortable with Python. For those students, I have added more comments than probably necessary, just to make it very clear. And once we try it anyway, we will go in the details of this line by line in terms of the explanation. Okay. We are not going to use any IDE. Don't use NetBeans, Eclipse, anything. We are going to use a simple editor. If you do not have a D drive, whatever drive you have, use C, for example, or whatever else you have on your machine. Okay, how many of you have completed the code? Just raise your hand so that I'll take a count in a while and then we'll decide whether to go to the next step. Not clear about the question. What do you mean by partially? Okay, let's now try this out. So first of all, copy the file. It's animals.txt, which we had created earlier, if you remember, in test files. Copy this file in our current directory in which we have put the code. right? So this animals.txt file, which we had in the test files directory, now we will copy under our current directory. Okay. And then open a command prompt in our current directory, that is, in my case, decode Hadoop Python. This need not be with the admin rights. It can be a simple command prompt. So we'll have a command prompt like this. And here we will run our code. We'll say type animals.txt python mapper.py.
Sir, the type command is like the cat command, right?
Yes. So if you remember the mapper logic in the diagram that we'd seen earlier, it simply does a count of 1 on each of the words that are occurring. So here also, for each animal that we have listed in our animals.txt file, it will say that the count is 1. Of course, we are yet to complete the reduce step. And in the reduce step, it will actually give us the final count. Here, we have just done the initial work of the mapping part. So we are inputting our animals.txt file into the Python mapper code, which is receiving this as the input. And then it is doing this mapping task. Code, of course, I'll explain line by line next time, but just to see that it works. Okay, very interestingly, I'm also observing that when I took the attendance, there were some 80 odd students. Now we have 55, out of which I don't know how many are trying. Okay, so I'm going to take the attendance quickly once again, just to see who all have disappeared. Division A, PRN 2.
Present, sir. Present, sir.
6.
Present, sir. Bearing, sir.
9.
Present, sir.
7.
Present, sir.
16. 28, 38,
38 present, sir.
41,
So 41 present.
46.
Present, sir.
Again, I suddenly see the numbers increasing because of WhatsApp, is it? 48,
Present, sir.
51, 52.
Yes, sir. 52.
I can't hear you. What was that? 52,
Sir, 52.
okay. 51, 54,
So 54 present.
56,
56 present, sir.
60, 69,
Present, sir.
73,
Yes, sir. 73 present.
24, 77,
Present, sir. 77.
78,
Present, sir.
80,
80 present, sir.
85,
Sir, 81.
okay, 85, 7, 89,
89 present.
91,
91 present, sir.
92, 96,
96 present, sir.
98,
So 98 present.
100,
So 100%.
103,
Present, sir.
104,
Yes, sir.
108,
Present, sir. 108.
Sir,
yes,
PRN 107 was annual disconnected during some time. Hello?
yes, okay. Division B, PRN 5,
Present, sir.
7, 8,
Present, sir.
10,
Present, sir.
12,
Present, sir.
17,
Sir, 13.
yes,
17 present, sir.
17, 19, 20,
20 present, sir.
24,
7 present, sir.
Present, sir.
26,
Present, sir.
7,
Present, sir.
89, 30,
Sir, 30 present.
31, 33,
Yes, sir, present.
34, 30,
Present, sir.
39,
Present, sir.
47, 7, 58,
Present, sir.
63, 6,
Sir, 66 present.
67, 68,
Yes, sir.
79,
Present, sir.
82,
Present, sir.
83,
Present, sir.
86, 90,
Present, sir.
99, 57, 63, 29, 92, 75. All right. You can tell the others who have disappeared that I have marked them absent. Okay. So,
Excuse me, sir.
yes.
सर 53 का माइक वर्क नहीं कर रहा, उसने चैट्स में डाला है तो शायद उसका स्किप हो गया था.
Sorry. What is the PRN?
सर इसका 53 है.
सर 28 इज आल्सो प्रेजेंट. मैंने चैट में डाला था बट एक्चुअली स्किप हो गया था मेरा, तो मैंने चैट में डाल दिया था.
Unnecessarily wasting everyone's time, but I have to do this because very clearly some of us are joining just to pinpoint when I'm taking the attendance and then disappear or ignore. Even others who are just for the sake of attending, not trying things, I'm once again telling you, just being here is not going to help. If you're not trying out things, you will suffer in your marks. And please be aware, this is an internal subject. Everything, all marks are internal marks. And this is your last semester. If you're not serious about it, you will suffer. Okay? And I've been trying my best to go slow, introduce each step. But if you don't show interest, if you don't try out things, choice is yours. Let me also state this very clearly in the big data subject of semester 3. So BCA semester 3 had big data subject, and there they had 15 backlogs, internal backlogs. Although it was entirely online. So just because it is online, don't think you will be able to clear it without really doing practicals, doing hands-on. It's up to you. In almost every lecture I have warned you, take it seriously, try things out. Don't be here just to give attendance, and even attendance wise, if you are taking such disadvantage, I am going to mark you as absent, which I have done today. So pass on the message. In spite of this, if you don't wish to take it seriously, of course, choice is yours. Okay, beyond this, I really cannot make you do things if you are not willing to do it yourself.
Sir,
Yes.
sir, just a request that before you just start the evaluations for this subject, please let us know like beforehand, like maybe 1 or 2 weeks before, 1 week at least, so that we can prepare.
I will, in fact, as per the college mandate, the dates for the assessments are more or less fixed. There are certain weeks during which the evaluations will happen, and I would stick to those weeks as much as possible. That
Okay,
will
so
be
you will
announced.
let us know, right, beforehand, at least 1 week beforehand.
Yes, I will.
Okay, sir. Thank you so much.
And again, those who are sincere, okay, those who are trying out things, you do not have to worry at all. Okay? I already am sort of guessing who those students are who are sincerely trying out things, who are really taking efforts to do something. Even if you don't succeed, that's okay. But those who are trying, those students do not have to really worry. You are doing well, and you will be able to clear all the internals easily if you are sincere enough. There is nothing really complicated about the subject. Okay, but I'm not someone who will say just because it is internal, let's take it casually. Everybody will pass. Everybody will get same marks. No, that will not happen. Okay, so unfortunately, I had to exceed the time just to re-emphasize this fact. So those who have disappeared, please tell them that they have been marked absent for both the lectures today. And if they continue like this, same story will repeat. Okay, but for those who are sincerely trying, well done, keep it up. And we will meet once again next week. Then take care, enjoy, bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.